All right, and welcome back. So today we are going to be talking about how to solve two and multi-step inequalities. In our previous videos, we've spoke about how to solve one-step inequalities using addition, subtraction, multiplication, and division. In this video, we are going to be solving two and multi-step inequalities, so any inequality that needs more than one step. So without further ado, let's begin. When we're solving inequalities with more than one step, we're going to approach it very similarly to how we would approach two and multi-step equations. In doing so, we're going to simplify both sides of the inequality first. We need to make sure that our left-hand side and the right-hand side of the inequality are simplified. That means we're going to be combining like terms, we're going to be using the distributive property, and we're going to simplify all the way down until we cannot simplify anymore. When that is done, then we're going to use inverse operations to isolate the variable. And a quick reminder, if we are actively multiplying or dividing by a negative number on both sides of the inequality, we switch the inequality sign. That is if we're multiplying or dividing by a negative number to get rid of that coefficient or get rid of the fraction that's with our variable. If that number is negative, we flip the inequality sign or we switch the inequality sign. We have to remember that we need to do that because that's really the major change between solving two and multi-step equations and two and multi-step inequalities. So let's go through an example. This is going to be an example that is found on your guided notes. We are going to be solving the inequality negative 5x plus 3 is less than 23. And our goal here is to find the solutions that make this statement true. So we want to find the values of x that when substituted back in will yield a positive, or not a positive, a true statement. Sorry. The first thing we do is we're going to rewrite it. Now that it's rewritten, we want to see, hey, can we simplify either sides of the inequality sign or are they already simplified? Well, we have negative 5x plus 3 on the left and 23 on the right. Jordan, right? We can't simplify anything on its own side. So we're going to use our inverse operations to move things around to get our variable isolated. So we're going to subtract 3 on both sides. In doing so, we have negative 5x is less than 20. So we subtracted 3, or if you want to think about adding negative 3 to each side, it's 6 to 1, half a dozen the other. Now we need to divide by negative 5 on both sides. When we do so, remember, we are actively dividing by a negative number. So since we are dividing by a negative number, we reverse the inequality sign. Thus, we receive x is greater than negative 4. And we're going to graph it. It's a greater than, which means we're going to have an open circle on negative 4, and we're talking about numbers bigger than negative 4, so we're going to shade to our right. Let's talk about how we are going to check this stuff, because we always want to make sure that we have our answer correct. There's a couple different ways to check it. We're going to use negative 4 as a possible answer and 6 as a possible answer. When we substitute them back in, we receive 23 is less than 23, which is not true, and 27 is less than 23, which is true. So since we know that when we plug negative 4 in, it's not a solution, the open circle on our graph is correct. The value of 6 is a solution, and that just should make sense because we're shaded over in the direction to that 6. We shaded to the right. Please now work on problems 1, 2, 3, and 4 on the guided note sheet and resume when you are ready to move forward. All right, if you listen to my voice, that means you have attempted problems 1, 2, 3, and 4 on the note sheet, and we are ready to move on. Sometimes we may need to use the distributive property, combining like terms, or we might have to even clear a fraction to simplify either side of the inequality. To clear fractions, let's go through an example. We can multiply each term by the least common denominator, or the lowest common denominator, also described as the LCD. Let's go through an example. Let's say we have 1/2 plus 2/6 x is less than 5/12. We need to figure out the lowest common denominator between 2, 6, and 12. Well, 2, 6, and 12, they all can go into 12. 12 is a multiple of 2, it's a multiple of 6. I always like to look at the biggest number and then see if we can turn it into that biggest number. We can't change 12 into 2. We can't change 12 into 6, but we can change 2 and 6 into 12. So we can always get bigger. We can't really get smaller. That's why we look for the least common denominator. Well, now that we identified the lowest common denominator, or the least common denominator is 12, we're going to multiply everything by 12. So we're going to multiply 1/2 by 12, we're going to multiply 2/6 x by 12, and we're going to multiply 5/12 by 12. When we do that, we end up with 6 plus 4x is less than 5, and this is an equivalent statement to our original. And now we have whole numbers, which might make it easier for us to solve the problem. A common error is that when we distribute this 12, we'll do 12 times 1/2, which is 6, but we'll forget we have to distribute to this other term of 2/6 x. So please make sure every single term in your inequality gets that lowest common denominator multiplied to it. Please, please, please make sure that that happens. Let's go through an example that is on the back of your note sheet. We're going to be solving 3/2 x plus 1/6 is greater than or equal to 5/3. So again, we want to rewrite it. We want to see if we can simplify on either sides. Well, 3/2 x plus 1/6, we can't simplify that by combining like terms. 5/3 is already simplified, but here is when we can multiply by that lowest common denominator. Now our least common denominator is going to be 6. So we multiply by both sides by 6. We do 6 times 3/2 of x, which ends up being 9x. We multiply 6 by 1/6, which is 1. We multiply 6 by 5/3, which is 10. So we get 9x plus 1 is greater than or equal to 10. We now want to isolate that variable. So the first thing we need to do is get rid of this positive 1. So we're going to subtract by 1 on both sides, or technically add -1 to both sides. Now we get 9x is greater than 9. And we divide both sides by +9. Since we're dividing by a positive, we do not need to switch that inequality sign because that is a positive number. And now we graph it. It's going to be a closed circle because we have a or equal to, and we would be shading to the right-hand side because number is greater than 1. Let's talk about how we would check it. We want to check it by using the number that we found is the number that we are comparing our variable to. So we're comparing x to 1, so we want to use 1 in one of our checks, and then we want to use a number that would satisfy this equation inequality down here. X is greater than or equal to 1, so 2 should be greater than or equal to 1, and we're going to double check and make sure that this is going to be a true statement at the very end. Well, we substitute in our values, and we end up that both of these are true, meaning that we did end up with the correct inequality statement. The endpoint 1 is a solution. That's why we did include it. We filled in that circle. And the value 2 is a solution because we are shading to the right, and we're talking about numbers greater than 1. After this, please work on problems 5 through 8 on the back of your note sheet. If you have any questions, please jot them below. Great job, folks, and we will work together in class.